All right, good afternoon, everyone. Want to follow up with a second video to walk you through just some SPSS syntax commands, how to use your syntax file, and how to set these up. SPS is nice because you can work with pull-down menus a lot, but as you start to get more comfortable with the program, you'll want to make use with your syntax files. One, it's going to save you time. Two, over the course of this class and next semester, we're going to have a lot of repetition. You're going to be doing the same things. So if you have like a standard syntax file that will take you through different screening and different procedures, a lot of that will save you time as opposed to having to generate it over and over again. And then finally, your syntax file is going to give you a record of things that you've done. If you're like me, you'll run some analyses and then set it aside for a couple weeks and come back and have no clue as to what you had done before. Your syntax file is going to be a nice way to go through and write notes to yourself to remember what you've done. So we're going to be using this SPSS demo worksheet we had gone through, started with in the last video. We're going to do the last half here with the syntax statements. Also posted a number of demo files that you can follow along with if you choose to do so. So first thing we're going to do, we're going to run through some of these different statements and different things you can do within the context of scoring some different variable or different measure data sets. This will be a nice way to get a handle on what some of these different statements do and how you can use these to manipulate data within SPSS. So the first file that we're going to be working with is this SPSS demo with a BDI2. Okay, just a measure of depression, 21 items on a scale from 0 to 3 in this measure. And so one of the first things we want to do in our syntax statement, particularly if we've had questionnaires that have been entered by hand, what we want to do is we're going to request some descriptive statistics. Okay, and in this sheet, I've got a note to myself that look at the data. All the data should range from 0 to 3. What we want to do here is take a look and make sure that we don't have any out of bounds values within the data set. Okay, and what this is going to do is it's going to give us descriptive statistics for the mean, standard deviation, min, and max. Okay, so here's what the statement will look like. Just to show you, I'll actually go through and show you how you can, for almost all of this stuff, request your these commands through your pull-down menus. For some types of analyses, we'll want to do this just because it'll be easier, but once you get a template, it starts to become nice to go through and just enter these by hand. So here we've got asks for descriptives. We've highlighted all the variables in this set, and we're going to hit paste. Paste is going to put this file into a syntax file here. New versions of SPSS will go through and tell you which set you're working with. I don't want to do that, but okay, so we've pasted this descriptives in. We're going to highlight it, and then we're going to run. And when we run these data, let me drag this here, what we see is that we've got our number of observations here, our minimum, our maximum, our mean and standard deviation. Now, mean and standard deviation in this example, I'm not terribly concerned about it, but what I want to do is take a look at the minimum and maximum. I want to make sure that I don't have any values that fall outside what's reasonable for this measure, 0 to 3. And so it looks like we're all good, but if we look down for our effective sample size here, it does look like we're missing some responses on some items. So we're going to want to take a look at that more closely. Okay, so we're going to shut this down. And so that gives us our descriptives. And so because we know that we've got some missing values, what we're going to do in this example is walk you through how you might go about prorating this measure so that you don't lose any cases. Here we're talking about person level substitution. We've got a measure a depression measure where we know all the items contribute to a single total score. Single total score is calculated as the sum of all items, but if we just sum it up without with some people missing variables, the people who are missing data are going to be have systematically lower scores than those people who have full data. And so we want to do something about this. So what we're going to do is we're going to prorate the BDI. And so what we're going to do is we're going to put commands that are going to sum the scores, the number of values, and calculate an average. And as we finish this up with this sort, what we're going to do is we're going to get cases with missing data on top. Now the first thing we're going to do is we're going to compute a sum statement. The sum statement in SPSS syntax is going to create a new variable called BDI2sum. So compute is telling us what to do. BDI sum2 is the name of the variable. And what it's going to do is it's going to sum all available variables within the listed series. Okay, so it doesn't matter if there's missing values. If there's a missing value on one of these items, it's going to skip it over. It's just going to sum all the scores that are available from BDI1 to BDI21. Now, when you're calculating your sum statements in SPSS, things to remember: you're going to write your command sum, and then you're going to put parentheses, and then you're going to put the variables in here separated with commas, close parentheses, and a period. If you don't do that, if you don't put in the period at the end, the parentheses, the commas, you'll get a screwy result. It won't do it. But what's nice is you should be able to take these and then just use this as a template for any other sum state you might want to count. So what we're going to do, first we're going to create a sum of all available scores, and then what we're going to do is we're going to create another variable count. We'll call this toCount, and this is, you can see, going to count all the values that we have available for BDI1 to BDI21 as long as those values are 0 to 4. And so what this is going to do is it's going to count the number of variables that we have a score for. Now, if one of those scores was out of bounds and was like let's say a 5, it's not going to count it in this count. But this is just a safety precaution. We've already gone through, made sure everything is within bounds. So our count should tell us for each case how many values are available. Okay. Then what we're going to do is we're just going to compute an average. We've got compute. We've got going to call this variable BDI2 mean. It's just going to be our BDI2 sum that we calculated here divided by our count right here. This is just a simple arithmetic statement. It's easy to set up in your syntax files. And then finally what we're going to do is we're going to sort cases by count. What this is going to do is it's going to take the cases with the least number of observations to the top. That's going to be the cases that we have missing data for, and so this will help us identify those scores that may need to be prorated. Okay, so what I'm going to do is I'm going to take this and copy this. We'll leave the count out. We'll just to show you how we would get that in through the pull-down menu, and you'll notice here that anything starting with an asterisk is a comment. SPSS is going to ignore that. It's not going to do anything with it. So any comments you want to make to yourself, throw in an asterisk and then type in whatever you want. So I'm telling myself this is syntax to prorate the BDI2. It's going to sum scores, number of values, calculate the average, throw everything there to the top. Okay, so I'll separate these statements just so you can see. So again, what we're going to do is we're going to create a sum of all the available data, count the number of scores available for each individual, and then calculate an average. So if I go through and I run that, we'll go down through. Always take a look at your output to make sure we don't have any errors. Looks like we don't have any errors here. If we go to our file and go to the end, we see that we've created a new variable, which is the sum of all available scores, the count, the number of scores we have for each person, and then the average. Okay, what this is this is an individualized person level average score that what we'll do, if we have cases that have missing values, we can go through and approximate or guess what that missing value might have been based on that person's individual average. Okay, there's research to suggest that person level substitution can be okay in certain situations. Here we've got a consistent scale where all items are highly correlated and load onto a single dimension, and so this is a reasonable alternative to just excluding anybody who happens to be missing a score. Okay, final thing though that we want to do is we want to see bring all the people with missing scores to the top. So what we're going to do is we're going to hit data, we're going to go sort cases, and we're going to sort cases by our to count. Remember, this is our count variable that we created. I'm going to hit paste. Okay, and here it is right here. It's the same thing as what we would have had here. I just wanted to show you how to get that through your drop down menu. If I run this, we can go through and we can see we've got, looks like 3 cases. Again, there's 21 items. We've got 3 cases that are missing values. Okay, now when I'm going through and prorating data, I don't, if there's more than a quarter of scores missing, in this case, if it's the measure is missing more than 5 values, that's going to be for me too much data. I don't want to go through and prorate that. And so this first case, we've only got 10 or 12 scores. And if we look, we can see we're missing a lot of values in here. And so what I'm going to say is I'm going to say this first case, who is this? 496, too much data. So we're just not going to have a score for the measure for this person. But here, we've got 2 individuals that are only missing 1 score. Okay, and if we go through, we can see the participant number here, and if we go through, we see for this first case, it looks like the average score of the 20 items available was a 1.9, and so what I would do here is prorate the missing value. It looks like we're missing BDI 13, as we're going to substitute a 2 in there so I can calculate a full score. Same thing here, the mean is 0.45 for this individual. They're missing item 1. Prorated value here rounds down to 0, and so what I would do is I would put a 0 here. Okay. Now one thing, and I can't emphasize this enough, if you're going to prorate data like this, you always want to keep track of what values you're putting where, so that if you ever needed to go back through, no one could accuse you of just making up data, right? What I have, and I posted this to the worksheets folder, is just a tracking sheet that I would print out, and for this first, I would write participant number 238, or excuse me, questionnaire would be BDI 2, subject 238, item, we're missing 13 on this, yep, item 13, write that in right there, and then the value for that missing item would be 2. Same thing here, we'd have BDI, participant number 486, item 1, value 0. Okay, again, incredibly important that you're keeping track of this, so that if you were to make an error or ever need to go back through and see where you substituted missing values in, you would have a record of that. Again, this sheet is available on course website. Please feel free to download it, use it for your own work as you're working through some of this stuff. So, okay, but for this demonstration, I won't worry about this. I'll go through and I'll say put a value of 2 for BDI 13 and a value of 1 here. Okay, and then that takes care of my 2 scorable cases for those missing values. All right, so what I want to do now, and see I've got a note to myself, don't prorate if more than 25% missing, more than 5 values missing, no score, just as a reminder to myself. Now what I'm going to do is I'm going to create a total score. You'll notice here we're doing the same thing with the total as we did with the sum. The only thing with this statement, when we're calculating this variable BDI2 tot, Notice that instead of a sum statement, we're using addition. With this addition statement, what this is going to do is it's only going to create a score for those variables with all with complete data. If we were to run this compute statement with the arithmetic sum in cases that don't have full data, like this one, what it is it's not going to produce a score. This actually works out nice because unless I've gone through and prorated everything, I don't want it to calculate me a score, and so that's going to be fine. Okay, so we're going to calculate this arithmetic total here, and then what we're going to do is we're going to sort cases by the subject number. And then what we're going to do, this is also helpful, you can write in your syntax statement instructions to label certain variables, give certain variables a label. And so this statement here, the command variable labels, is saying to telling it for BDI2 tot, which is the total score that we're calculating here, to label this as BDI2 total score. Okay, so what I'll do is I'll highlight this just so you can see. Okay, one thing you'll notice, if you have a comment that's right next to a command that isn't separated by a space, it won't read it. So you want to make sure that you separate that out. Same thing here. We're going to sort variables, labels. Okay, so here we're going to run that addition statement. Syntax is saying, or output saying it's doing what it's supposed to be doing. Notice that we have score for all of our variables that have full data. These now have full data because we substituted that mean for that missing item. But case number 496, we don't have a score for this one because we're missing too much data. And with the arithmetic addition here, it's not going to create a variable for that. So we just know that we don't have a score for this individual because they missed too many responses. So what we'll do is now we'll sort our participants by subject number. Okay, and then what we'll do, and if we go down through and we take a look, you see we don't have a label for BDI2 total. But if we run the syntax statement telling variable labels BDI2 tot, and then in little, what are those? Not parentheses, but little quotation things, BDI2 total score, we hit that, and we see that we've given ourselves a label here. So not that you couldn't just type that in, but if you're doing a lot of scoring, sometimes it's nice to have all that automated. Okay, BDI2, these three we don't need because those were just used to calculate things. So we'll go through, right click, clear those, and we've got it all set up. Okay, so this is an example of some basic stuff here with a BDI2. We'll go ahead and close that out. What we're going to do is pull up a different file. This is our demo. This is our PRI, another name for Marlowe Crown Social Desirability. You'll notice here that we'll start over here. You'll notice here that looking at our descriptives, in this case, we've got a dichotomous response. We've got data ranging from 1 to 2. Okay, so this is going to be good. We're going to want to make sure that all of our values, actually here we'll just go through. And drop that in here. Come on now. Paste, get a new syntax file for this next demonstration. Okay. All right, going through running this. So here, our data should be from 1 to 2, But if we go down through and take a look, we've got scores that are 0 here, 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 and here. So we've got 0 scores, and these are problematic. 0 is not a valid entry for this, and so I need to go through and fix this. So we've got, for have doubts about ability to succeed, it's going to be our PRI 5. We sort this. There's our 0. Get rid of that. What else do we have here? Going down through. Always courteous. Always courteous. It's PRI 21. Sort that. All right. Never make long trips without checking my car. Is PRI 27. Okay. And again, I'm just right clicking and then hit sort ascending. Get rid of that. And then never felt I was punished without cause. Is 31. And then there was one on our last variable here. So we're sending here. Okay. Now, if this was my actual data, I would want to go through and check my actual hard files to figure out what was going on. If this was a data entry error, if someone just wrote in a 2, something like that, would always want to double check that before I would move forward. But for this example, we'll just pretend that the participant wrote in an invalid score. And so what we're going to do now is go through and calculate a count, because what we want to do is see how many of these cases we're missing data for. So we're calculating a variable called count, again just using our count variable, collecting scores 0 to 2, or excuse me, 1 to 2. Count this. We go through. Okay, so we see we are have one case that's actually got nothing in there, so we can clear that out. But what we do is we've got several cases. Okay, there's a 33 item measure. We've got, looks like 8 cases, 9 cases that are missing a score. Okay, now this is tough because these are dichotomous responses, and taking the average of a dichotomous response is not the same as a continuous scale. And so what I'm going to do is I'm probably just going to, I guess for this case, leave these unscored, at least for right now, until I could go back through and take a look and see what was going on. So the tricky thing here with this code is we're going to have to use a recode statement. So when we're having participants, or research assistants enter these data, we had them entering 1 is true and 2 is false. Okay, which makes sense. 1, 2, true is false, easy to enter, but doesn't actually map on to what we need in terms of scoring this measure. Okay, and so what we're going to do is we're going to tell SPSS to recode these variables. And so we're telling it to recode 1, 2, 4, 7, 8, 13 onto 33. And we're going to say if the data, if the set has a value of 2, we want to change that value of 2 to 0. Because what it's going to do is it's going to change 2, which is a false statement, to 0, which makes more sense for our coding. Okay, and then once we've done that, what we're going to do is we're going to take the true statements 3, 5, 6, 9, 10, 11, 12, 14, 15, 19, so on, that are going to be scored as 1, are going to make these 1 as 0, and if they're 2, we're going to equal those, set those equal to 1. This is just going to do some reverse coding with these items. Okay, so if we go through now, the thing to note is that generally, most often, always, what we want to do is we want to recode these variables into a different variable. We'd have PRI3, PR3R, 5R, 6R, so on and so forth, because as soon as you go through and do this, it's going to change your data, and if you screw this up, you're going to lose it all. Okay, now we've got a system for this scoring here, so we're recoding them into the same variable, but something that you want to be careful of. Okay, so we're going to very dangerously put this recode statement in, and again what this is going to do is it's going to say for these variables, any of those variables that have a value of 2, we're going to change that to a value of 0. Okay, so we're going to highlight this, run it, and we'll see now that for these variables that previously were 2, they're now going to be equal to 0. Okay, and so these are items that were straightforward coded where 2 was equal to false, where it actually was scored as a false response. Okay, but we are also going to have some items that are going to be reverse coded. These reverse coded items are going to be items where in some cases a true response is going to be scored as a 0, a false response is going to be coded as a 1. So for example, if I were to have a depression measure and I were to have an item that were I'm happy all the time, true or false. Well, if it's a measure of depression and we're scoring towards depression, what I would want to do is take that true statement, make it false for the item I'm happy all the time, and turn that towards depression. What we're doing here is the same thing for each one of these items. These are reverse item codes in the set. So a score of 1, which would be an indication of true, is now going to be 0. Turn that to false. Those that are a 2, you can see, so for PRI3, here we've got a bunch of 2s in this column. We didn't code those because those 2s that had indicated a false in the original entry are now going to be set equal to 1, indicating a true response. So we'll go through, change that, and you see now that we've got all 0s and 1s consistent with how the measure is intended to be scored. And so what we'll do now is we'll compute our total. Oops. I'll grab that. And then our labels. Oops. Okay, and so I just want to make sure that I don't have comments right next to things. So again, I've got my addition statement here, and so when I run this total score, we'll see that those items, or that those cases with missing data, don't have a score. And then what we'll do is we'll label this PRI total variable as PRI total, and then sort ascending, and we've got it squared away. Okay, all right, I'm gonna shut down this one and then open up and get into something that's a little more involved. Okay, this one, so we've got a measure, an interview measure of post-traumatic stress disorder here, and in this measure, what we have for different items is we have ratings of the frequency and intensity of different symptoms. Okay, and so what I want to do is I want to first open up my syntax statement, and I'll drop these in here and paste this into a file. Okay, oops. Grab a new file. All right. So with this measure, what we want to see is make sure our scores are following from 0 to 4. They are in fact doing that. It looks like we have some missing ratings for some of these, but everything is in bounds, so we're happy with that. Okay. What we're going to do is we're just going to start by calculating a total score. And in this case, sometimes we're going to be missing scores. For example, a symptom of this disorder is lack of memory for the accident. And sometimes people are knocked unconscious, and so it doesn't make sense to code loss of memory if people were unconscious, and so we wouldn't code that in this set. And so we're just going to calculate our total score as the sum of available ratings, recognizing that sometimes certain ratings aren't going to be applicable to people. So we've got a total score here, and then we're going to look at how many items are missing from individuals. If something were to happen where we were to be missing a whole lot of data, we might wonder about whether or not we should score that. So we're creating a total score here, looking at how many are missing as a count variable, and then sorting the file by our count variable that we create. Okay, so we go through, you can just highlight the whole thing, run this, and we see of the 34 items, we have a couple people that are missing, looks like one frequency and intensity of one symptom, a couple people that are missing a couple of symptoms, and someone who's missing quite a bit, but we'll still score it, I guess, and then a couple of people who don't have a score. So we could conceivably get rid of them, but we'll just leave them in there for now. But everything looks reasonable. Okay, so what we're going to do is we're going to count 3 different symptom clusters. We're going to count re-experiencing symptoms, again using a sum statement, avoidance numbing symptoms using a sum statement, hyperarousal using a sum statement here. Okay, and you'll see why this is all important before too long. Okay, paste this in, and again, once you've got the hang of this, you can then, once you have your own syntax files, can copy and paste from other things, and change just the items for whatever measure you're doing, and just plug these in here for your sum statements. But I'm going to go through, calculate these individual scales here, take a look at the end of the measure. Okay, so we've got our scales here, pretty much what we've been doing before, so we're happy with this. Here's where we're going to start to get a little bit tricky. One of the things that you can do with SPSS, with these statements, is specify if-then statements. And what this will do is SPSS will conduct an operation only if the data meet certain conditions. For example, if we wanted to count the number of values between 1 and 4, only if variables have certain properties. And so in this case, what we're telling it to do with this first statement is we're saying do if, right? It's giving it this if-then statement. If frequency of symptom 1 is equal to a 1, right? So this wouldn't count, but this would, this would, this would. If the frequency of symptom 1 is greater than or equal to 1, and the intensity is greater than or equal to 2, then what we're going to do is we're going to count, we're going to create a variable called Q1, question 1, and we're going to count the number of values for in frequency and intensity 1 to 4. Okay, and so what this is going to do is it's telling the program that if, for example, this case where intensity is greater than 1, greater than or equal to 1, and intensity or frequency is greater than or equal to 1, intensity is greater than or equal to 2, it's going to count both of these as values for, so the value for Q1 is going to be 2 because we've got 1, 2 values. But if we go down, let's say to this case. Okay, frequency is greater than or equal to 1, but the intensity is not. And so for this case, SPSS won't provide any score here, because this case, the frequency and intensity items for symptom 1 don't meet this do-if statement. Okay, and then we're going to do the same thing for symptom 2, symptom 3, symptom 4, 5, 6. Within the context of this assessment, the way this measure is scored is things only count as a clinical symptom if we have a frequency rating greater than or equal to 1 or intensity rating greater than or equal to 2. So what this is going to do is it's going to go through and it's going to give us a count variable, our Q1, Q2, Q3, only if those symptoms meet diagnostic threshold. Okay, so we're just going to go through and paste that in there, because with this measure we've got 17 symptoms. And so we're just repeating the same thing for each one of those 17 symptoms. Okay, so if we pull this down, right, you can see we got a long stretch here, but what's nice is it's repetitive, and you can go through and set this up on your own if you needed to do something like this. And we can go through and we can hit run, and it looks like it did it, no errors. And if we go to our data set and look at the end, we see here Q1, Q2, Q3, 4, 5, 6, all the way through 17. And we see that we have a marker here for cases who meet diagnostic criteria for a given symptom. We've got a 2 there as a placeholder, given the way we've scored this syntax. Okay, so this is good, but what we want to do now is we're going to recode these Q variables, Q1 to Q17, and if we have a value of 2, we're going to set that 2 and replace that with a value of 1. And if there's system missing, that's what the sysmiss command or sysmiss indicates, that we're just going to leave that as missing. If we wanted sysmiss to equal 0, we could pop 0 in there, and then for any value that for any symptom for each individual that didn't meet, we would have a 0 there, but we won't worry about that for right now. So we'll take this recode statement and run that. Okay, and you'll see all of our 2s are now 1s. Okay, and now what we can do is we can count how many symptoms each individual meets within each cluster. So what we're going to do is we're going to count. We're going to create a new variable called reexcret, avoid crit, hypercrit. This is going to be measure counting how many symptoms within each cluster an individual meets for diagnosis. I apologize to you experimental folks. This is probably going to mean less to you or people who aren't trauma researchers, but hopefully you'll get kind of the idea of what SPSS is doing and how you can start to set up data files to do things that are a little more elaborate here. So we'll go through here. Okay, so we're going to create 3 new variables. We're going to count the number of symptoms meeting criteria for our re-experiencing cluster, our avoidance cluster, and our hyperarousal cluster. If we go through, hide this, run that, no errors, we're doing good. Okay, so here, for this diagnosis, for each one of these symptom clusters, we've got the number of symptoms within each cluster that meet diagnostic criteria, right? So here we've got someone with 4 re-experiencing symptoms, 2 avoidant numbing, and 2 hyperarousal. Here we've got someone with no re-experiencing, 1 avoidance, 4 hyperarousal. And then what we can do, finally, is what we want to do is we want to count the number of people who actually meet criteria. For PTSD. At the time that we were collecting these data, people would meet criteria for diagnosis if they had at least one re-experiencing symptom, at least 3 avoidance symptoms, and at least 2 hyperarousal symptoms. And so what we've got here is a statement that says, do if individual has 1 or more re-experiencing, 3 or more avoidance, and 2 or more hyperarousal symptoms, we're going to have a new variable that we call PTSD crite, and we're going to count the number of values within each one of these, 0 to 7, and then we're going to recode those data to create a diagnostic variable. Okay, so you can see if we go through and run this conditional statement here, we'll see that here we've got people that met for 2 symptoms, right? Whoops, no. So here, someone met criteria for re-experiencing, but they missed on avoidance, made for hyper, so we don't have a count here. This one had more than 1, 1 or more, 3 or more, 2 or more, so we've got a count of 3, 1 or more, 3 or more, 2 or more here. This one met here, missed here, and so they don't have a value, again, because we're only creating a count variable if re-experiencing is greater than or equal to 1, avoidance greater than or equal to 3, hyperarousal greater than or equal to 2. Okay, and then the last thing we can do is recode our PTSD crit so that any system missing, so any of these values that don't have a value, we're telling it to recode sysmiss as 0, and any value of 3, which is the only value that it can have, equal to 1. We run this, and now we have a variable that has our PTSD diagnoses. Okay, and what's nice about this is that if we were to go through, and this may all seem very tedious, but if we've got this scoring syntax down and we know that it's all right, what's nice is we can just go through, run our descriptives, see that everything's all good in the hood, and then you just highlight the whole thing. We can run all of it. Boom. It gives us all of our scores, and then we can go through and we want to say, okay, how many people in this sample met criteria for PTSD? Go through and take a look, and it looks like, at least in this modified set, remember that I've changed all these, so don't try and publish this because it's falsified data. But in this hypothetical example, we've got about half of the sample meeting criteria for PTSD. Okay, so last thing we're going to do, and thanks for bearing with me here, but important to note that I had talked about the dangers of recoding variables. I want you to pull up this NOS demo here. Okay, what we're going to do here, and again, so we've got another variable, another data set, where we've got, there we go, where we've got all of our items loading onto a single scale. Okay, so we've got 20 items. That are ranging from 1 to 4, okay? But the tricky thing with this is that we've got some recodes, right? So we have things that say, oh, I like to ask people for help, I'm fine with that, which in terms of this measure is measuring willingness to utilize help. So some items are things like, well, I'm fine with asking for help. What we would need to do is reverse code that item before we would score this up into a total. And so what we're going to do is we're going to have a recode statement here that we're going to paste in. And so this one is different. This recode statement, recode into, is going to recode values into a new variable. Okay, and the benefit of this, and the strong benefit, and I strongly recommend that you do this, is our original values are going to remain the same. Recoded scores are going to be their own new score. That way, if we screw anything up, we've still got all of our original scores, and we're not flipping things around here. So in this case, item 3, 5, 8, 10, 12 are going to be our recode variables, where a value of 1 equals 4, 2 equals 3, 3 equals 2, 4 equals 1. We're just flipping those around. But then we're saying into NOS 3R, 5R, 8R, 10R, so on and so forth. What this is going to do is it's going to create a new set of variables. So here we've got NOS 1 to 20. What we're going to do now is we want to run our recode statement, and what you'll see is we've got a new set of variables. We've got 3R, 5R, 8R, and these are our recoded values for those items that need a recode. Okay, and it's nice because we still have our original data. We haven't changed that. We've just got these values for those individual items that need to be flipped around that we're now going to use in terms of our scoring. Okay. So we've got our prorating statement. Again, not going to prorate if we're missing more than 5 items, but notice that here with the reverse coded items, we're going to have to be careful, because what we want to do is we want to enter an adjusted score. And in this situation, basically this is a larger data set that we keep adding to, and I don't want to recode or re-enter these every time I would go through and score this. What we're going to do is we're going to have people go through, enter the prorated value into the original variable, so that when we then recode it, it turns in the right variable. So, for example, if I find a mean value of 1 across this recode, what we would do, and that missing value happens to be a recode, instead of a 1 for that, we would enter a 4 into the original variable, recognizing that when we run the recode, it's going to flip that into the right, or excuse me, 4. Here we go. If we have an average of 1 on the recoded value, we'd punch in a 4. That way, it reads that 4, flips over to 1, so that it's the correct value that it should be. So, and I think I've set this up so that we get some of these. So let's go through, and all of this is nothing new. It's stuff that we've gone through before. So here we've just got our statement telling us what we're doing. So we're going to create a count variable that tells us how many values we have. We're going to create a sum that's going to add up all the available scores, regardless of items that are missing. We're going to create a mean here, and then we're going to sort by the count to see if how many cases we have that are missing variables. So we're going to run this. Looks good. Go to our data. Oh, and also notice that here in our count and our sums, we're adding up we're using our reverse coded items here. So we got 1, 2, 3R, 4, 5R, 6, 7, 8R. So this is our actual scale, making sure we're getting the right average here. So in terms of missing values, we've got one case. It's missing too much data, so we're not going to use that one. So we'll leave that alone. We've got 2 cases that are missing a single value. All right. And interestingly enough, the value here is, we'll say, for the purpose of this, we'll say 2.47 isn't 2.5. So we'll count that as values of 2, I guess, for this purpose. Okay. So want to go through, and again, on our sheet, mark for NOS, participant 108, we're missing a score for item 4. Okay, so we write item 4, and then value for the missing item. If we go through and take our syntax, so 4 isn't a recoded variable. 4 is just 4, and so what we would do is for we'll say a value of 2, we'll go through and our prorated value of 2. What happens now is this isn't a recode variable, so it's just going to get added up like it would normally prorate. This one, however, if we go through and see item 1 or participant number 125, NOS 125, item, oops, looks like 17 is what we're missing. 17, all right. But if we go through and take a look here, or in our syntax file, item 17 is a recode, okay? For item 17, original value of 2 is going to be equal to 3, okay? And so if we want a value of 2 to be scored, and this is a recode, what we need to do is we need to enter a value of 3 for item 17, because what then is going to happen is this, our scoring syntax is going to take that value and turn it into a 2 when we go through and recode. So we want to actually enter a 3, even though our prorated value is a 2. In the original item, we're going to enter a 3, because when you flip that back around in the recode, it's going to turn it into the correct value, which is going to be a 2. Okay, so we've gone through and done that, and then copy and paste the rest of our syntax file in here. Yikes. Okay, so we're going to recode again. Okay, I'm not sure what I did there, but okay. So what we're going to do, so we've gone through, prorated it, and we're saying delete sum, count, and mean after prorating. We would do that. But what we're going to do is we're going to rerun this recode statement, because we've put values back into the original variables. And so we're going to recode these variables, and then what we're going to do is, instead of a sum, we're just going to run an addition statement here. Remember, the difference between the addition and the sum statement is the addition is going to not provide a value or a score for any case that's missing values. After we've gone through and prorated any case that doesn't have a value in there, probably we don't want a score for, so that works. We're going to label our variables, our NOS total, and then we're going to sort by ascending. Run through and do that, and there we go. Okay, we don't need our count, sum, mean. We can get rid of those. Run back through here. Okay, so hopefully this helps give people a sense for how to set up syntax, some different types of basic scoring types of statements that are going to be, I guarantee, useful for theses, dissertation, research projects, papers, and things like that. Getting comfortable with this programming language is pretty straightforward. It's pretty easy. The more complicated stuff that we'll do, we'll use pull-down menus. But for this type of thing, once you get the hang of it, it's easy to cut and paste in from templates from previous syntax files, or just, you know, calculate opposite side. I mean, so you want to compute scrap equals NOS 14 plus NOS 19 times 2, right? Pretty easy, straightforward, and if you go through and run that, sweet, didn't give me an error. We can see here at the end, we just got a new variable. It starts to become kind of second nature after we've done this a bunch. So hopefully this was helpful. As always, let me know if you all have questions about any of the things we've done here. Again, this modified demo sheet will be available in the handouts folder. I'll put these demo sets in for you to play around with if you so choose. Also take a look. I'll post this prorating tracking sheet in there, again, just so that you have something so that you're taking good care of your data, making sure that you're keeping track of anything that you're changing there. Okay, so thanks. We'll see you guys tomorrow. And again, shoot me an email if you have any questions.